Have you ever heard of the bridge that wobbled so much it had to be shut down just 2 days after it opened?
Well, that's exactly what happened to London Millennium Bridge back in the year 2000. It was this stunning,
futuristic-looking footbridge connecting St. Paul's Cathedral to the Tate Modern, and thousands of people flocked to be the first to walk across it. But as soon as the crowd stepped on, something very strange began to happen. The bridge started to sway from side to side. It wasn't a gentle rocking either. It was a noticeable, unnerving wobble that made people feel like they were on a boat in rough seas. So what went wrong? It wasn't a simple design flaw or because the bridge was weak. The real culprit was a fascinating phenomenon in physics called synchronous lateral excitation. It sounds complicated, but the idea is actually quite simple. When the first person stepped on the bridge, it moved just a tiny bit sideways. To keep their balance, that person instinctively adjusted their next step, pushing back against the sway. Now, imagine thousands of people doing this all at once. Their footsteps, which started out random, began to sync up. Everyone was subconsciously pushing off at the same time to counteract the bridge's movement. This created a feedback loop. The more people swayed to keep their balance, the more the bridge swayed. And the more the bridge swayed, the more people had to adjust their steps, all in perfect, unintentional rhythm. It was a crowd-powered wobble. The engineers had accounted for vertical forces, like people bouncing up and down, but they hadn't fully anticipated how this synchronized side-to-side motion from so many people would amplify itself. The bridge was nicknamed the Wobbly Bridge, and it was closed for almost 2 years. During that time, engineers went back to the drawing board. They couldn't just make the bridge stiffer. They needed a more clever solution. They installed a series of dampers. Think of them like giant shock absorbers. There were 2 types: viscous dampers, which are like pistons moving through thick fluid, and tuned mass dampers, which are massive weights designed to swing out of sync with the bridge's motion to cancel it out. These dampers effectively absorb the energy created by the pedestrians' synchronized steps, preventing the wobble from ever building up again. The bridge reopened in 2002, and it's been perfectly stable ever since, a testament to brilliant engineering problem solving. It's a great reminder that even with the most advanced designs, the real world and the people in it can always throw you a curveball, or in this case, a wobble. Thanks for watching. If you found this interesting, give this video a like and subscribe for more stories about the amazing science and engineering all around us. See you next time.